Okay.
Good morning, everyone. Wow, okay. That's loud. All right, so I'm just going to keep talking until Franco shows up. So Franco, if you're here, you're going to have to stop me. Good morning. My name is Dan Kozlowski. I am the Minister of Engineering at a company called PlanetScale. But that's not really what I'm going to talk to you about today. I'm going to talk to you about what I used to do, which is I used to work for a company called the United States Digital Service, which, if any of you are familiar with GDS in the UK or other government technology transformation companies or businesses that do that, the United States Digital Service was one of those. So I wanted to talk a little bit about what the wonderful organizers called Day 2. And they define Day 2 as what happens after you actually have everything up, deployed, configured, usable. So you have your Kubernetes cluster, you have all of your storage, it's attached, it's provisioned, it's connected to the internet, it's ready to go, but then somebody has to use it, right? It's not actually how it goes. Like, obviously no one would walk into a technology deployment and then set everything up and then ask themselves how they're going to use it. But logically it kind of makes sense. So a little bit of background. The United States Digital Service, their mission is to create a better government through technology. So I know that we are in Europe, not in the United States, but I imagine anybody here who has to deal with their government probably has the same problems. If you've ever had to deal with government technology, probably doesn't work that well for you. Most governments have a real struggle with technology. This happened to the United States when they rolled out a new piece of legislation that called for a web portal to allow people to register themselves for healthcare. Over in the States, we get to buy our healthcare ourselves. It's not given to us by the government. So we had this wonderful website, and as soon as it went live, it crashed and burned, and no one was able to use it. And it was kind of a turning point for the government to realize that anything they wanted to do was going to have a significant technology component. And up until that point, it was kind of an add-on, right? Like, you make a policy, and then somebody will go figure out how to actually make it work with the internet or on a computer. And this was really like front and center. This was part of the package of, we are going to let people self-service sign up for healthcare, and it didn't work. So they got a bunch of technologists together, and they said, please make this work. And those technologists had the foresight to say, we can fix this one thing for you. That's not a problem. But the real problem is there are tens of thousands of government applications that are in just as bad a shape as this healthcare.gov that nobody actually pays attention to. So why don't we fix this for you, show you what we can do, and then we will plug in to do the rest of the government. So I was not a part of that team. I joined them later. Oh yes, as part of that, which is going to be key later on as I talk about this, is that they actually plug in at the White House. The original team that did this, they reported to the Obama White House. When they went out into the different agencies, they reported to the secretaries of those agencies. So that is the highest level of leadership that you can get. There is nobody else above that. And this was very important for the USDS, and keep that in mind, because that is going to be very important when we talk about Day 2 of migrating into cloud-native storage. So, from my experience, when I showed up, I got assigned to the Department of Veterans Affairs. The Department of Veterans Affairs is the government agency that oversees benefits for the 90 million American veterans, people who have fought in wars. And it's quite an interesting agency. It was founded after the American Civil War in the late 1800s, I believe. And by the time I had showed up, they had actually already done technology modernization once. They went from pens and papers to computers. And what was interesting to me is they went from pens and papers to computers well before I imagined governments knew what computers were. So we're talking about the 40s, 50s, and 60s that they started modernizing onto digital systems. So when I showed up, I'm talking to people who are working on a mainframe system from the 1960s. And this is the mainframe system that was responsible for collecting, storing, and reporting on data for 90,000 American citizens. But wait, there's more. Not only that, they also had something around 350 data centers by the time, and I was there from 2016 to 2018. So by the time I was there, they had 350 data centers spread all across the world, actually. They had about 75,000 computer applications, and these numbers are approximate because part of what I realized was that nobody actually knew these numbers. There was no one place you could go to and say, where are your data centers? Nobody knew where all the data centers were. And nobody knew where all the applications were. So that was part of the challenge. They had millions of daily active users. And I mean, this wasn't people looking to serve ad tech, right? These are people who are trying to look up their prescriptions. These are people who are looking to schedule doctor's appointments, would like to find out about their health care, would like to find out about their burial rights, things that really impact them on a day-to-day basis. And then, to top it all off, the VA is a healthcare company, so they're subject to all the regulations of healthcare companies. They're an insurance company, so they're subject to all the regulations of insurance companies. And they're a benefits company. They pay out a lot of money in benefits, so they have a lot of accounting and finance regulations. They're a government agency, so there's a lot of security regulations on top of it. And because each individual agency in the United States gets to make up their own rules, they also had a bunch of things on top of it. So when we got there, we walk into this situation. We have 350 data centers, 75 million applications, about $4 billion a year spent on IT, and we wanted to make it better, so we embarked on a cloud modernization push. One interesting thing, I don't know what all the companies are represented here is, but I think there's two different kinds of companies that are embarking on cloud modernization. There is the ones who own their own data centers, right? They have their own data centers, they have their own storage, and they want to move into the CNCF world. So there's one set of challenges that deal with that, and that may be setting up your on-premises Kubernetes cluster, migrating your storage arrays from whatever SAN network you had to something that will work with CNI and will be able to play with Kubernetes nicely. That's one set. There's another set, which is people who had their own data centers, and they're not really in the data center business, so they're trying to move into the cloud, Amazon, Google, Microsoft, the likes of those, as well as trying to move into something like Kubernetes. And then that gets really confusing because we say, we're making a cloud migration. And they say, right, you're moving to Amazon. And we say, no, we're actually moving to Kubernetes on Amazon, and that's a little bit different than just moving to Amazon. But when we got there, there was a specific application we targeted that we said we wanted to move into Kubernetes on Amazon out of a legacy data center. There was a lot of challenges that were associated with that. Eventually, we got it all sorted out, and we did get the application up and running on Amazon. But really, since this is day 2, I'm not going to tell you how we actually got it all up and running on Amazon, because that was interesting enough. But I'm going to tell you what we learned about the process of managing and running it. And it actually goes beforehand. So the whole process I want to talk about is configuring, managing, and migrating our stateful applications from an on-premise data center to Amazon in the cloud. And here are a few of the lessons that I learned. So that part that I said about how we reported into the White House and the secretaries is super important, because at any point in time, if you're trying to make this migration, if you want to go from legacy stateful applications in a legacy data center, to something that is cloud native, and you want to be successful, this is not a technology change, right? It's an institutional change. You can look up a lot of work, a lot of papers that have been written, a lot of articles that have been written about how people react when you tell them that we are turning your legacy application into a platform and that it's going to be self-service. If any of you have had to have this conversation, maybe with IT departments at the companies that you work, this generally doesn't go over well. Being plugged in at the highest level is important, because what you're going to see is things like your org charts. They're not going to apply anymore, or they're not going to apply in the same way. There's probably headcount associated with the legacy systems that is not going to be needed anymore when we move into a cloud native world. This is particularly true if you're going from on-prem to something like a cloud provider, like an Amazon or a Google, there is going to be a lot of people, and these are people who have jobs, those jobs support their families, that are not going to be doing the same things that they used to do. So if you were just plugged in at the low level and say, I have an application, we're going to move it into the cloud, we're going to move it into cloud native technologies, it's going to have a lot of friction, a lot of pushback from your organization, and it's probably going to fail. The second thing that you have to sort of go into this with is, what do you actually want from your modernization? A lot of times people will say, we want cost savings, it can be cheaper. That's not always true. I can spend a lot more money on Kubernetes than I ever could have spent in a legacy data center. Or they may say we want enhanced reliability. When we talk specifically about stateful workloads, a lot of people will point out that it's a lot cheaper to run things in the cloud, but then we talk about the reliability of stateful workloads, and in my experience, the reliability of stateful workloads has not been a huge selling point of Kubernetes up until this point. I think the questions that were being asked last time about detaching and attaching volumes, if you've dealt with Kubernetes in production, you've probably ran into that situation where your pods won't schedule. Your stateful pod won't schedule because it was the scheduler is trying to run it across availability zones, and you can't mount the EBS volume across availability zones, so now your whole application is down, and your wonderful, reliable Kubernetes system has now just caused a multi-hour outage, and everybody wants to know why they were sold this bill of goods about a super reliable system that has now gone down on a failure because some low-level tech cycled an instance. So you have to ask yourself what you want, and you have to plan accordingly for what you want out of modernization. And then the last thing that has to happen at the institutional level, which is kind of tied to the org chart, is, in my case, 75,000 Kubernetes clusters, independent, isolated Kubernetes clusters, is just across the board worse than whatever else we had. In fact, I can't think of something that would be much worse than 75,000 independently operated Kubernetes clusters across an organization. That, to me, would have been an abject failure. So this was part of the culture that I was dealing with at the VA, that we had each individual team, because they were being provided compute, storage, and network capacity from the underlying IT ops organization, they were then responsible for their own runtime environment. And there was 75,000 different operations teams that all got services out of the corporate IT network mesh. If they just moved that into Kubernetes, that would have been a nightmare. 75,000 different clusters trying to do upgrades, trying to maintain security, trying to maintain policy and permissions, it just wouldn't have worked. So that was the first lesson, that most of the change that you're going to see, especially on these day 2 operations about configuration and migration, is going to happen at the institutional level. So if you don't have the institution on board and wanting these changes to occur, that's your first challenge. You have to make that argument to them that there is a reason to do this. The second thing is, if you are coming from a legacy IT operations world, the point that humans should not be involved is really hard to get across, especially in storage. Like, this is the level of the system that people really care about. I remember hearing, and I don't know where I heard it, that data has gravity. Like, it is the mass of the system. And when we start talking about making changes to that or shuffling that around different data centers, people start to get a little leery. But it's really important that if you want to be successful, humans should not be involved, right? When you talk about defining your persistent volumes, humans should not be defining your persistent volumes. The computer should be doing it. The level of people who are dealing with your infrastructure should know about the applications that are running on it, but the applications ought to be dealing with an API, not by calling somebody up and asking them to attach a block volume to an instance. This is, again, another thing that people really had a hard time with, especially with data, because I think one of the examples that was showed up here showed that the reclaim policies can be set to keep, not delete, right? And when we run, the company I work with now, when we run workloads on the cloud, we have the reclaim policy set to keep because we are playing with other people's data. But if you were to change that to delete, how would that make you feel inside? Like, think about that. that if anything happened to your volume, configuration change, all of your data would be gone. People get really anxious about that. And so that has a knee-jerk reaction to kind of not allow anybody to do anything. We don't want to allow you to attach storage. We don't want to allow you to detach storage because we don't want anything bad to happen to it. Thankfully, I don't know who put that reclaim policy in, what Kubernetes developer put that in, but it was absolutely genius because it's really easy to then go say, no, 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 we're going to allow computers to do things. We're not going to have humans involved. But we'll set the reclaim policy so that worst case scenario, somebody can come back and fix your mistake. The last part about humans not being involved is that provisioning and planning, they need to be automated. Again, you can have an IT organization where you have to call and ask for a server and ask for SSH credentials. You're not going to get whatever output you think you're going to get off of moving to cloud-native technologies. If you're still relying on humans provisioning things, it's not going to work out the way you think it is. I don't have a clock up here, so I actually have no idea what time it is. So I'm just going to keep talking. Thankfully, this is my last slide. All right. So the last lesson that I learned is that humans absolutely have to be involved, right? So that whole business about humans not being involved, gotcha. So there's a set of things, and this was the big takeaway for me when we were trying to modernize the application I was trying to modernize. We had a specific requirement, right, that the environment had to be geographically survivable. So if something happened to an entire half of the continent, this application had to be online. My first response to that was, if something has happened to half of the continent, do you really care if this application is online? But since that was the requirement, we spent an inordinate amount of time trying to get our Kubernetes clusters to federate across regions. It was an absolute waste of time. It was an absolute waste of time. Things like, I am convinced at this point in the cloud-native lifecycle, things like disaster recovery absolutely should just be handled as manual processes. So it is fine to automate your backups, and you should have automated backups, including the automated testing of your backups. But that plan where the entire half of the country suffers a blackout, maybe that's okay for a human to get involved to reset a DNS address, right? The amount of work that we had to put in to handle that one case, we should have just let humans do it and went about our business. A similar story goes for things like upgrades or hardware lifecycle events. If you imagine today, if you operate a Kubernetes cluster, if you want to swap out a node, in theory, you can just pull the power cable off the back of that node and good stuff will happen, right? Everything's gonna take care of itself. But the reality is, if you want to do something like a hardware lifecycle, if you want to swap out an underlying compute node, you cordon the node and you drain it, right? And that's perfectly okay. There's no reason why it's bad for a human to actually go through, mark a few nodes as having to be decommissioned, allowing them to drain, and allow that to come back online. The last part there is hooks for human approval. So I had mentioned already about the reclaim policy about allowing a human to approve the deletion of a node is a perfect example of where you have a good balance between computers doing things automatically, but then there being a hook for a human approval. So having the hook for human approval is I delete the node, it sort of goes into a special state, or I delete the storage volume, it goes into a special state, but then I come along later as a human, I look at the nodes that have been decommissioned, I validate that yes, they are in fact okay to be removed, and then I remove them manually. Okay, so that's a few of the lessons that I learned at the USDS as we were migrating applications. There's obviously a lot more to it. But the one that I just want to stress with leaving, change must occur at the institutional level. If I've said anything of value, it's that one. So, thank you.
Thank you so much, Dan. That is exactly the kind of information I was hoping that you would give our audience. Okay, let me see if I shouldn't have let Dan go because he actually knows how to do this. Yeah, right? It's this one, right? And then he went to, Franco's is, I had it queued up. No, it's not that. It's, shoot, where did it go? Are there more?
Oh, stop that. Stop that.
Okay, then I guess we'll just go here. And it's that one, yeah. Open up the slide. Cool.
Franco, the policy is while we're having IT issues, you have to tell jokes.
That was the policy. If you'd like to tell a joke, even in Italian, because that would sound really cool. And then I wouldn't know if it was funny or not, but I would love it. It just takes a long time to open. There's a lot of content.
Okay.
That's what we'll call it. Perfecto. Perfect. Do you prefer this type of microphone or that type of microphone?
No, it's fine.
Okay.
Okay.
Great. Thank you.
Okay. Good morning. My name is Franco Fiorese. I'm part of the DXC company. We are doing mainly IT services, and we started about 4 years ago, working on a container platform, starting at the early time, and we work mostly in the public sector in Italy, and also on other large clients outside of Italy. And our work was related to the implementation of a container DevOps platform. So the experience we have is that very often we got a lot of problems. It's not easy to take care of this kind of platform because they are quite complex. So this is an example of what we learned from the recent past, where we had a critical application running critical service for the public sector, and at some point everything went wrong. So the problem is that it's very difficult to predict this and also to take action on this, understanding all the various elements and then the part of the platform. And in the end, we found that the main problem were related to the poor AOPS of the system. And that means that many of the resources on the cluster are not tuned a bit in the right way to cope with the workload. Also, the architecture of the cluster was not probably the best one regarding the storage. And there is a network congestion. Most of the traffic on the network includes the storage packets. And so that contribute to make even worse the situation. And in some cases, we also went into delayed sync replication across the nodes because we had shared storage across the nodes. And also, the last one is related to the software issue on the cluster. And on Kubernetes, you need really to keep all up to date, but doing a lot of updates in time create a problem because you need to be careful about the updates and keep the cluster safe and running. Our best practices that we learn from this experience is that first we need to have a real, let's say, great team. We need to have very skilled people working into the team. They need to know very well the environment. They need to know how to cope with all the issue, and there is a need to have a very strong collaboration. So they need to know each other very well. And they need to work in an interactive way. That's the reason because in our platform we use a lot of chat ops and also we automated all this interaction. And also the process are very important. And the last one is about the software defined. Because we must have all software defined, we need to do as much as we can automated process. And all the artifacts that are needed for the software-defined process need to be recorded and stored on Git, just to be sure we have everything up to date and we can keep track of the version. This is, for us, it is very, very important. And then we need to adopt a data layer management software to make it easier to perform volume orchestration, migration of data, and so on. Probably this is the only reason because we use only for this part a specific vendor's solution, in this case Portworx. all the software we use is open source, but for some specific situation, we need to have something that is not available on the open source world. And this helped us a lot in this. We need to simplify the container management volumes, I mean the life cycle. And for that, we come up with our own solution, and I'll show you this later. And we need to plan for at least, in our situation, two tiers of storage volumes. One for stateful application. One is low performance, and one is high performance in terms of I/O throughput. And also we need to use a reliable solution to collect all metrics, log, and in general events coming from the application that are running on top of the cluster. This helps us to troubleshoot any issue, and this must be run all the time, 24/7, no matter how complex it is. And of course, we need to also to perform backup of data just to ensure that all the data of our clients' application is safe. And also, the last one is related to the plan for disaster recovery, how to recover from a fault. So let's go into the life cycle of stateful application service. This picture shows you about three main aspects. The one is about design, develop, and compose, where the developers create the application and through software-defined process create the infrastructure asset. In this case, everything goes up to the registry, and also we use Git for the composition file as well. Then we need to go into the build, test, deploy, when we start using the images from the registry and creating application running on the cluster. In this case, we created a specific tools here, and is some sort of preprocessor of the manifest file that can manage the creation of volumes automatically, and so making it easy to avoid error, and taking care also to the role-based access control to the specific feature of the platform. This is some sort of filter, so it's not possible for any user to use a common compose or manifest file. It needs to go through this process to be vetted and to check that it's okay for us from a process point of view. The last one is about the operation. During the operation, we use another specific software. In this case, it's a tick stack from Influx Data. So we use an InfluxDB to collect all logs, metrics, to correlate them, and to be sure that where is a fault or there is a problem, we can get all the information we need at the specific time. Because it's time series database, this is quite easy to do with that. It's just a matter of configuring it. And also, from a Portos point of view, we are using two different architecture. One that is taking care of using low performance volume. So we have a dedicated cluster for the storage and for the stateful application. So all the application running on top of the node will get access to this shared storage through the Portos driver. The other one is for high-performance application, in which we have the nodes inside with the storage inside, so hyperconverged. And this is very important because when you start running database application in a container, you need to get the real I/O you need, and you cannot, let's say, do this if you don't have a direct attach into the volumes. At the same time, Portos ensure us that whenever a container will migrate from one node to another, it's automatically reattached to the right volumes. All these at the bottom is regarding software assets. So we need to maintain track of config, definition, scripts, and so on. Everything stored on Git. This allows us to have a single truth of source for all the artifacts we need, and to cope with any need in terms of recovery in case we need to recover any service. I'll show you now just a few things. Our platform is based on three main areas, as I said before. So we have the design, develop, compose, the build, test, deploy, and operate. we follow some main principle. For us, it's very important that the single unit of delivery is an application service. So it's not just a single container. Just from an end-to-end perspective to keep track of what's happened in a specific application stack. And we use fully integrated tools for communication, in this case, ChatOps. And I show you here, this is the architecture, basically. And all the modules are connected through an API gateway, so we can collect all the information we need, give access to a specific function using access control to the platform feature. And also it's very important the use of the RBAC feature of the platform to allow specific people to get access to resources they can get access to, so to have the right privilege for that. Last one, is related to the fact that this kind of let's say, platform require a very continuous updating. So the technology is quite fast. Every 2 or 3 months there is something new. And so we need to cope with that. So we need to have something that we call, in this case, some sort of wiring concept, in which we can detach a component and attach a new one in case it needs to be updated. Or maybe, in some cases, we can use 2 different tools of the same species together. For example, we could use together GitLab and GitHub, or maybe we can use together the tools for the continuous integration, like Jenkins, Go, CDGO, or Drone. The same would apply for the rest. So the API gateway allows us to do this trick quite easy. Last word is related to the enhanced storage solution, as I mentioned before. This is more related to the products of Portworx, so maybe you can go and see about that directly from them. But essentially, this is very important because for us, because allow us to have a great control of the platform in terms of stateful application services. So that's all for me.
Thank you. If you want to stay here for 1 second, and also, Dan, don't run away. Does anyone have any questions for Franco or Dan? I know Franco can't stay all day. I don't know, Dan, if you're going to be around all day to help answer questions, but okay, Dan will be. But does anyone have any questions for Franco or Dan right now before we let them go? Jared has a question. Hang on. Oh, there's stairs over here. Who knew?
So yeah, Franco, on one of your slides, you were mentioning it was important to do frequent benchmarking for I/O. And how do you manage doing frequent benchmarking in a production environment and not hurt the availability or the performance of that production environment?
Good question. Yeah, well, actually, our solution is based on instances. When we deliver our solution to a client, we have a dedicated instance for them. So we have in-house dev test platform that is the same that we deliver for the client. So we do the same test here on that one, and just to compare with a different one. And usually we do the test using specific tools. For example, we benchmarked Oracle database, although it's not supported running in containers. And we had a very good results in the end. So it was quite useful. We do this kind of test very frequently, every three times in a month.
Yeah, so to continue what you asked, you talk about IOPS. Yesterday at the CEF event, which is upstairs today also, they were also talking about the latency. So do you measure any latencies?
No problem. No, yes. In the public sector in Italy, we want a deal in which we are running OpenStack as a platform, and we use CEF. We switched from an enterprise storage that previously was Reaper. Now we're running on CEF, so hyperconversion node. And we check every time the latency. Unfortunately, it's not a constant one. It's very various. So we need to cope with that, and usually we keep some spare value for I/O. So if we need 1,000 IOPS, surely we give 1,200. And also we do some tuning on the Ceph part. Another possibility that we were thinking about is running a dedicated Ceph cluster just for container, just to be sure to have the best performance and minimum latency for that.
Okay. Any more? We might have time for one more question, if there are any. Otherwise, Dan is going to stick around, so he'll be here. You know what he looks like now. Thank you, Franco. Thank you, Franco, and thank you, Dan.